On today's show, we'll hear from Dr. Jake Hebert, physicist and research associate with the Institute for Creation Research. Here's Dr. Hebert.
In 2012, a theoretical physicist, Big Bang proponent, and professing atheist Lawrence Krauss wrote a book entitled A Universe from Nothing, in which he tried to argue that the laws of physics permitted a universe to pop into existence from nothing. Now, of course, this is a ridiculous claim, and we've already critiqued it in an earlier episode of Science, Scripture, and Salvation. But in a number of places in his book, he made some derogatory comments about theology, basically saying it was of no practical value, and yet people used to consider theology to be the queen of the sciences. It was held in very high regard. Now, Krauss's attitude really isn't terribly surprising. If you're a skeptic, if you're someone who claims that there is no God, then of course you're going to claim that theology is relevant. In that case, it would be a pointless field of study. Why study the Bible if it's merely a human work? The study of theology is only meaningful if God actually exists. But in his book, on page 144, Krauss made an interesting statement. He said, "I have challenged several theologians to provide evidence contradicting the premise that theology has made no contribution to knowledge in the past 500 years at least, since the dawn of science. So far, no one has provided a counterexample." Now, I would like to take Krauss up on his challenge and provide a counterexample, and a very important one at that. Good theology provided important insight that led to the discovery of the principle of conservation of energy, which is one of the most important rules in all of physics. Now, energy is kind of hard to define in a way that isn't circular, but a lot of textbooks will say that it is the capacity to do work. And this rule of conservation of energy says that energy cannot be created or destroyed, although it can be transformed from one kind to another. In other words, the total amount of energy in the universe remains constant. So to kind of illustrate this, let's use an example. There's two kinds of energy that we often talk about in physics. One is called potential energy. That is energy of position, energy that is there because of the relative positions of two objects. And you also have what is called kinetic energy, or energy of motion. As an example, let's say you're an astronaut standing on the surface of the moon. We're using the moon as an example because on the moon you don't have to worry about air drag, which is a little bit of a complication, and so this will make our calculations a little bit simpler. So let's say you're an astronaut, you're standing on the moon, and you're holding a golf ball in your hand, and you drop it. Now, because of the ball's height above the moon's surface, there is what we call potential energy, specifically gravitational potential energy. Now, the instant you let go of the ball, it's not moving. It has no energy of motion. It has no kinetic energy. But the total energy is the sum of the kinetic energy and the potential energy. As the ball falls, the potential energy decreases, but the ball gains kinetic energy. And so at any given height above the moon's surface, the sum of the potential and kinetic energies will stay constant, but as the ball falls, the amount of potential energy decreases, but the amount of kinetic energy increases. So finally, just before the ball hits the lunar surface, all the energy is kinetic energy. So that's a simple example of conservation of energy. Now, we could have done the same experiment on Earth, and the total amount of energy would have still remained constant. Now, the calculations would have been a little more complicated because then you've got air drag and you have to worry about that. But had we carefully accounted for all the different forms of energy, we would find that the total amount of energy the instant we released the ball was the same as the total amount of energy just before the ball hit the ground. So energy is always conserved. This is true in any process, no matter how complicated. The total energy of the universe stays the same. It can be transformed from one form to another, but it's neither created nor destroyed. Now, you may be wondering, what on earth does all this have to do with theology? Well, that's what we're going to discuss in our next segment. So stay tuned.
Dr. Hebert.
In the previous segment, we discussed how biblical skeptic Lawrence Krauss has claimed that theology has made no contribution to knowledge in the past 500 years. Now, we're challenging that, and what I would like to do is point out that there is a very famous Bible-believing scientist named James Joule who made a huge contribution to our understanding of the principle of conservation of energy. By the way, many of the founders of modern science were Bible-believing Christians. They took the Bible very seriously, which is in contrast to what we see today with so many high-profile scientists taking an agnostic or skeptical position towards Scripture. But anyway, James Joule did this ingenious experiments, and he showed that the amount of friction needed to raise the temperature of 1 pound of water 1 degree Fahrenheit was consistently obtained from the same amount of mechanical work, 772 foot-pounds. Now, we can loosely define work as the product of a force and distance. And so if you exerted a force measured in pounds through a distance measured in feet, so that the product was 772 foot-pounds, that's the amount of mechanical work that gives you the friction needed to raise the temperature of 1 pound of water 1 degree Fahrenheit. So this was a very important step in developing a formal statement of conservation of energy. And this is such a big deal that physicists have named a unit of energy after James Joule. It's called the joule. And getting a unit named after you in physics is a big deal. We have a unit of force, the Newton, for instance, that was named after Isaac Newton to honor his contributions to physics. So in the same way, we honor Joule's contribution by having a unit named after him. Now, what many people probably don't know, however, is that James Joule was motivated in his studies by his theology. He was a devout Christian, and he stated his belief that only God can create or destroy. And this is what he said. He said, believing that the power to destroy belongs to the Creator alone, I affirm that any theory which, when carried out, demands the annihilation of force is necessarily erroneous. Now, he said force, today we would say energy, but he's basically saying that any theory that requires the annihilation of energy or the creation of energy is erroneous. So here we have a very important counterexample to Lawrence Krauss's challenge. James Joule made a huge contribution to physics, and he was motivated by theological considerations. In fact, James Joule had chapter 9, verse 4 inscribed on his tombstone. I must work the works of him that sent me while it is day. The night cometh when no man can work. And he also had the numbers 772.55 inscribed on his tombstone. And of course, that's the amount of mechanical work that we had discussed earlier, measured in foot-pounds, that's required to raise the temperature of 1 pound of water 1 degree Fahrenheit. Now, I would imagine that even Lawrence Krauss would concede that conservation of energy is extremely important for physics, but if you read his book, A Universe from Nothing, it's basically an attempt to find loopholes in conservation of energy so that a universe can just pop into existence all by itself. And you can only wonder what James Joule would have thought of that. So here's an example of how an extremely important contribution to science was motivated, at least in part, by theology. But theology has contributed to science in a lot of other ways. ICR's Dr. Jason Lisle has done a lot of work in this area. In order for modern science to be possible, certain things have to be true, things that we often take for granted, but we have no right to expect those things to be true except in a Christian worldview. So for instance, one of the things that you have to take for granted when you're doing science is that the information we obtain from our senses about the world around us is basically reliable. That's because you're often making observations in physics or chemistry about the world around you, and you have to implicitly assume that your senses are giving you reliable information. Now, there's a good, firm, biblical, theological rationale for that. God is truthful. He's not trying to deceive us. He's not the author of confusion, as it says in 1 Corinthians chapter 14, verse 33. So we have good reason to believe that since God created our senses, we should be able to trust the information coming from those senses. Now, if you don't have a Christian worldview, you can't really assume that. For instance, how do you know that you're not some disembodied brain in a laboratory somewhere and somebody's got electrodes going into your brain, feeding you stimuli to make you think that you're sitting at home listening to this radio broadcast? Well, except from a Christian perspective, how do you prove that? How do you prove that the world is not an illusion? There are some religious sects that say the universe is an illusion. Well, what's the point of doing science in a universe where everything's an illusion? We are told in Scripture in Proverbs chapter 1, verse 7, that the fear of the Lord is the beginning of knowledge, but fools despise wisdom and instruction. And that is certainly true. It's true about theological knowledge, and it's also true about scientific knowledge.
Thank you for joining us on Science, Scripture, and Salvation, a radio ministry of the Institute for Creation Research.